Welcome to another one of our videos in our YouTube channel Inquisitive Engineer. And the last video that we did was some codal provisions regarding the design of slab, and it was related to the design of seismic resistant RCC residential building. And today I have thought about starting a new video series, and this video series will be about concrete reinforcement and detailing. Actually, I wanted to continue with the design of slab because we looked at the theoretical portion regarding codal provisions and the behavior of one-way and two-way slabs in our previous lecture. And I was thinking about, and I also told you that we would do the design of a two-way slab in our next lecture. But before starting with the design, I think we have to learn something about detailing of slab. So I wanted to start a new video series, and I wanted to start this video series on concrete reinforcement and detailing with the detailing for restrained two-way slabs. Because while performing or while constructing a building or performing any work on our site, we are not concerned with how the design is performed. We are always concerned with our construction drawings, the drawings that have been prepared based on the design results. We are always interested in the detailing of those structures, beam, column, slabs. We are not concerned with how the design is performed, but we are only concerned with what is the result or output of that design. And concrete reinforcement detailing is one of the output of design. So let's begin with our first video lecture on this video series or lecture series, whatever you may call, by starting with detailing for restrained two-way slabs. So ESP34, we have ESP34, that means special publication number 34, and that was published in 1987, and it is a handbook on concrete detailing and reinforcement. ESP34 is a handbook on concrete detailing and reinforcement, and many points and many pictures that I have used in this slide or in this first video of this lecture series are based on the criteria enlisted in ESP34. And in ESP34 section 9, there are conditions or there are points to be followed while detailing floor slabs. So you can download this ESP34 from the internet and have a look. We have studied that the minimum reinforcement in solid reinforced concrete slabs is 0.15% if the bars used are plain bars, whereas the minimum reinforcement is 0.12% where high yield strength deformed bars or welded wire fabric are used. And this minimum reinforcement is calculated and it is expressed as a percentage of the gross cross-sectional area of the concrete. Similarly, the minimum cover to reinforcement in case of slabs shall not be less than 15 mm, nor the cover shall be less than the diameter of the bar. The main bars in the slab shall not be less than 8 mm, and the diameter of the bar shall not also be more than 1/8 of the slab thickness. That means when you divide the thickness of the slab by 8 and get a value for that, the diameter of the bar should not be greater than that value. And finally, when restrained slabs are designed by using the moment coefficients given in table 26 NXD of IS 456 code, they should be detailed as per clauses D1.4 to D1.10 of the code. If you can remember, in our last video lecture of the design video series, we talked about using moment coefficients for the design of slabs, and those moment coefficients are given in NXD of IS 456 code. And in that NXD clause, there were some clauses from 1.4 to 1.10 that I just read out in our last lecture but did not go into detail. I also said that we would go into those points when we were designing the slab. So our detailing is based on those same clauses, D1.4 to D1.10 of the code, and this means these 6 or 7 clauses are from NXD of IS 456. So this is about introduction to the detailing of restrained slabs. So before going into detailing criteria of restrained slabs, Let's first look at the detailing criteria or detailing of two-way slab supported on 4 brick walls. So this is not a restrained slab. This is a case of simply supported slabs, and that slab is supported on all 4 sides on brick walls. So how do we detail a two-way slab supported on 4 brick walls? First, you know that a two-way slab means either it should be supported or simply supported on any of its 2 sides, or the ratio of the length of the longer side to the length of the shorter side should be less than or equal to 2. If one of those 2 conditions is met, then we call that a two-way slab, and the load distribution will be on 2 sides, both sides, that means. So let's look at this figure. Here we have the plan area of the slab, and we have got 2 sections in this plan area. One is along AA, and that AA section is shown here, and another section we have cut along BB, and that BB section is shown at the bottom. So LX is the effective length in the shorter direction, and LY is the effective length in the longer direction. We have these are the center line of the supports or center line of the brick wall that you can see here on both these figures. So let's look here. These 2 rebars or these 2 rods, whatever you want to say, are the reinforcement in the shorter direction, and these 2 rebars are reinforcement in the longer direction. So as the slab is spanning in both directions, that is, it is a two-way slab, the reinforcement in each direction shall be considered as main reinforcement. So both of this reinforcement in the shorter direction and longer direction, both are main reinforcement. The bars in the shorter direction are generally placed in the bottom layer and tied with the bars in the longer direction. So let's look here. If you look at this section BB, these bars which are at the bottom, these are sectional view of bars placed in the shorter direction, and these bars in the shorter direction are always placed below the bars in the longer direction. So in section BB, these bars in the shorter direction are seen as a dots, and in section A, this is the bar in the shorter direction because this is the section along AA, and the dots above this bar are the bars in the longer direction. So remember, the bars in the shorter direction are placed at the bottom, and those are tied properly with the bars in the longer direction, which are kept at the top of those bars. And this should be tied because we should make it sure that the rebars or those bars do not move or do not displace during the process of concreting. And at least 50% of the tension reinforcement provided at mid-span should extend to the supports. So let's look here. So let's look here. What does that mean? At least 50% of the bars should be extended to the supports. That means, let us look here. If we are considering this bar, the bar in the longer direction in this section BB, suppose that the area of these bars or the area of this reinforcement in the longer direction is AST, and this AST is always per unit width because we design slab per unit width considering a beam of unit strip width. So if AST is the area of this bar, at least 50% should extend into the reinforcement. Sorry, at least 50% should extend to the supports. That means, let's look here. From this point here, 50% of the reinforcement is extended to the top side, and the remaining 50% is extended into the supports. So 50% is 0.5 AST is cranked and taken to the top of the slab, whereas remaining 50% is extended into the supports here. So at least 50% of reinforcement should extend into the supports, and the remaining 50% should extend to within 0.1 times the length in the shorter direction or 0.1 times the length in the longer direction of the support. In the longer side 0.1 Ly, that is 10% of Ly, and in the shorter side 0.1 Lx, that is 10% of Lx. So this top bar, if you can see here, this top bar is bent from here and taken to the top of this slab. So for this top bar is at least at a distance of 10% of Ly. This 50% bar is extended into the supports, this bottom bar, and remaining 50% is taken to the top to resist the negative bending moment at the supports. And from which position or from which point is it taken to the top? After this bar reaches to a distance of 0.1 Ly, then only it is cranked here and taken to the top. So similarly is the case in X direction. 50% of the bar is extended into the supports, which is this bottom bar, and the remaining 50%, after it has reached to a minimum distance of 0.1 times Lx, that means here that 50% bar is cranked to the top portion. So three main points to remember here. First, the bars in the shorter direction is kept at the bottom, and the bars in the longer direction are kept at the top of those short direction bars and tied properly. 50% of the reinforcement should extend into the supports, and another 50% of the reinforcement should extend to at least 0.1 times Ly or 0.1 times Lx, depending on the side of the slab, whether we have taken the shorter side or the longer side. So this is about the detailing of two-way slabs supported on 4 brick walls. Now let's look at the detailing for restrained two-way slabs. This is the main topic for our this first video series, our first video of this lecture series. So restrained slabs, you already know the corners are prevented from lifting, that's why they are called restrained slabs. And section 9 of SP34 deals with the detailing of solid slabs, and in that section 9, clause 9.4 deals with the, or clause 9.4 lists out some important rules regarding simplified detailing for restrained slabs. And these rules are again based on the clauses D1.4 to D1.10 of IS 456 code. So clause 9.4 of SP34 and clauses D1.4 to D1.10 of IS 456 are the same. When restrained slabs are designed by using the moment coefficients given in table 26 of NXD, that means, if you can remember, we designed our slabs based on moment coefficients, that is, moment in X direction is the bending moment coefficient in X direction, alpha X into W, this is the load, and Lx square, and the moment in Y direction is alpha Y W and Lx square again. So these bending moment coefficients alpha X and alpha Y are listed out in table 26, and this formula is given in clause D1.1 of NXD. So, and we calculate these moments and then we detail the slab based on the clauses of the same NXD, clause D1.4 to D1.10. So first point was that the maximum moments calculated is in D1.1 of IS 456 2000. That means the previous two formulas that we saw, mx and my. Those maximum moments that we have calculated from that formula apply only to the middle strips, and no redistribution shall be made. If you remember, IS code allowed us to divide our restrained slab in measure two portions. One is the middle strip and other two are the edge strip. Same is the case for another direction. One is the middle strip and other two are the edge strips. The width of these edge strips is 1 by 8 times the length of that direction. That means for longer direction it is Ly by 8, Ly by 8, and for shorter direction it is Lx by 8 and Lx by 8. And the remaining width 3 by 4 Ly or 3 by 4 Lx is the width of the middle strip. So we can divide our restrained slab on into edge strips and middle strips. And continuing with those clauses in Annex D, another point is, first we divide the slab into two strips, middle and edge strips, and then what it says is that the tension reinforcement provided at mid-span in the middle strip. Let's read it again. The tension reinforcement provided at mid-span in the middle strip shall extend in the lower part of the slab to within 0.25 times the length of a continuous edge and 0.15 times the length of a discontinuous edge. For example, if you look at this, it may be small for you, but I think you can see it clearly. If you look at this figure here, there are rebars or there are bars on the bottom which are seen as dots here, and these are bars in the shorter direction, because we saw in our previous slide the bars in the shorter direction are kept below, and this long line which is drawn above these dots are the rebar in the longer direction. And what you can see here is that there is a cutoff point here and there is a cutoff point here. We know that the rebars in the middle strip, this is somewhat middle zone, these are the tension reinforcement for the slab, because at the mid span the deflection of the slab will give tension at the bottom. So these tension reinforcement should extend in the lower part of the slab within 0.25 L of a continuous edge. Look here, 0.25 Ly1. Ly1, here if you can see here, I have divided these spans using different colors. This green color boundary means this is one panel of our slab. This red color boundary is another panel of our slab. This is continuous in this side and continuous here. This blue color boundary gives us another panel, and this yellow color boundary gives us another panel. So if you look at this green colored panel, Ly1 is the length of the longer side and Lx1 is the length of the shorter side. So in this continuous edge, our rebars or our bars in the bottom are extended up to 0.25 times the length of this longer side, whereas in the discontinuous edge or in the free edge it is extended up to 0.15 times L1. So the tension still that is calculated for the positive design moments. That means the bottom bars at the short and long spans in the both spans should be provided as shown in our figure, and these are provided at the bottom of the mid span in the middle strip in both short and long span directions, and these bars should extend to within 0.25 times the length of that direction, either Lx or Ly, and 0.15 times the length of that direction, either Lx or Ly, for continuous edge, 0.25 for continuous edge and 0.15 for discontinuous edge. And in doing so, we have to remember that alternate bars should extend fully into the support. That means one bar will extend up to 0.15 times L1 and another bar will then extend fully into the supports. If you look at the plan view, let's see here, we have this bar here which is extending up to a distance of 0.25 times the length of this Lx1, and this bar is cut off here or curtailed here. Now another bar, if you see here, this bar is extending fully into this support here, and but only up to a distance of 0.15 times in the free edge. So alternate bars should extend fully into the supports and another alternate bar should be curtailed. So this is the detailing of tension reinforcement provided at mid-span in the middle strip of our restrained slab. So continuing with this, another clause states that over the continuous edges of a middle strip. In our previous slide, we talked about the tension reinforcement curtailment in the bottom of the slab itself. Now what is here? Over the continuous edges of a middle strip. This means this is the continuous edge and this is the continuous edge for our this green boundary panel. The tension reinforcement shall extend in the upper part of the slab at a distance of 0.15 L from the support, and at least 50% shall extend a distance of 0.30 L. So now this clause gives us the curtailment of tension reinforcement in the upper part of the slab. What this clause says is that the tension is still calculated for the negative design moments since it is at the edges, or since it is in the continuous edges. The tension is still calculated for the negative design moments in the short and long spans at continuous supports should be provided at the top and uniformly distributed across the edge strips of the short and long spans. So that means at least 50% of these bars should extend to a distance of 0.3 L from the face of the continuous support, which we are seeing here. At least 0.1, this is 0.15 and 0.15, so this is 0.30 L. At least 50% should extend up to 0.30 L, and the remaining bars should extend only up to 0.15 L. You can see cutoff point here and here also. So 50% bar will only extend up to this position, and remaining 50% will extend up to 0.30 times the length in this direction. So this is about the distribution of or curtailment of, or detailing, whatever you may say, of tension reinforcement in the upper part of the slab. And finally, at a discontinuous edge, negative moments may arise. They depend on the fixity at the edge of the slab, but in general, tension reinforcement equal to 50% of that provided at mid-span extending 0.1 times the length into the span will be sufficient. We talked about continuous edges in our previous slide. Now in our discontinuous edges, the tension reinforcement at the top that is designed for negative moments should extend at least up to 0.1 times the length in that direction. So reinforcement in edge strip parallel to the edge shall comply with minimum reinforcement requirement. We talked about middle strip. In edge strip, our requirement for reinforcement shall comply with the minimum reinforcement requirement, that is 0.12% in the case of high strength bars and 0.15% in the case of plain bars. Now let's come to torsional reinforcement. If you can see on the diagram here, you see that if this is our slab, our edges or our corners are being lifted up, and this lifting may be due to various reasons. And as a result of this lifting up of corners, there are cracks at the bottom of the slab. You can see these are cracks at the bottom. So torsional reinforcement has to be provided at the corners of our slab if they are prevented from lifting. And this torsional reinforcement can either be provided with the help of these skew bars or these bars parallel to the side of our slab. And generally, this method of detailing is provided bars parallel to the side of our slabs. So let's go through the points here. Torsional reinforcement shall be provided at any corner where the slab is simply supported on both edges. That means for this corner, both these edges should be selfly supported and is prevented from lifting unless the consequences of cracking are negligible. The torsional reinforcement should extend at least a minimum distance of 1/5 of the shorter span from the edges. So this distance, suppose if this is our corner and our torsional reinforcement is placed like this, then the span of this torsional reinforcement should be at least equal to 1 by 5 times the length of this shorter span of this panel. In all 4 edges, you have to put or you have to detail in similar way. And this is about the length and the area of reinforcement per unit width in each of these 4 layers. Why 4 layers? Because a torsional reinforcement will be provided in horizontal and vertical direction. So this is 2 layers. So one set of 2 layers will be placed at the bottom and one set of 2 layers will be placed at the top. So there will be 4 layers. And the area of each of these 4 layers shall be 3/4 of the area required for the maximum mid-span moment. So the area of this torsional reinforcement is based on the reinforcement at our mid-span, and it should be 3/4 of the reinforcement required for the mid-span moment. So this is about torsional reinforcement. You can see here 1 layer, 2 layer, 3 layer, 4 layer. This is placed at the bottom and this is placed at the top. And the area shall be 3/4 of the area for mid-span moment. And these should extend at least up to a distance of 1 by 5 times the shorter span. So this is the case, this reinforcement is the case when both edges of these corners are simply supported. Now if only one edge is simply supported and another edge is fixed, then torsional reinforcement detailing is done in such a way that the area of each layer is now not 3 by 4 times but 3 by 8 times the area. 3 by 8 times the area. So remember this, if both edges of this corner are simply supported 3 by 4 times the area, if one edge is simply supported 3 by 8 times the area, and if both edges are fixed, then or in cases where our both edges are continuous, then we did not provide torsional reinforcement as they are already restrained from lifting. So this is corner with 2 discontinuous edges and this is corner with 1 discontinuous end. And finally, this figure shows the overall simplified rules for curtailment of bars. And the curtailments can be done in 2 ways, either by giving crank bars as you can see at the top, or by simply using straight bars as you can see at the bottom. Both methods are applicable, but generally nowadays we don't crank the bars, we usually use straight bars. So let's just revise by using this, looking at this diagram. Our tension reinforcement at the bottom, 50% of the reinforcement should extend into the supports and 50% should be taken at least to the point of 0.15 times the length in the discontinuous edge and 0.25 times length in the continuous edge. For the top bars, which is designed for negative bending moment, here 50% of the bar should extend to a direction 0.15 times L1 and 0.15 times L2. L1 is the span of this section, L2 is the span of this section, and remaining 50% is 0.5 AS2 should extend to a direction of or to a distance of 0.3 times the span of this bar. And this is for continuous edge, and for discontinuous edge, at least up to a distance of 0.1 times L1. So this is the distribution of bar at top and this is the distribution of bar at the bottom. So this is the end of our first lecture video on this series of reinforced concrete element detailing. And today we looked at the detailing for restrained two-way slabs. If there are some topics left to be covered with the detailing regarding slabs, we will cover that in the next lecture. Or we may also continue with our previous lecture series on design and look at the design of reinforced concrete two-way slab. So we'll meet again soon. Thank you.